So this is a section that's going to be big time applicable in calc, okay? So you just want to make sure that you kind of get the idea. So I'm going to be asking if a function is odd or even. I'm not saying this. That's even. That's odd. Because if I went like this, how would you know if that's even or odd? If I went like this, how do you know if it's even or it's odd? So there's a way to find out if a function is even or odd, and I'll show you that. It's also based on the reflection, okay? So we'll talk about that. So actually I'm going to put my glasses on here. So if I graph this, this is my parent. I need you to be good at parent. And if I graph this, it looks kind of like this. I bet you would agree. If I was to graph this one, it's going to look something like this. I need you to be good at those. If you're not sure how the shape's going to look, I think that page that I showed you in the previous video, this is all the shapes. Get good at these shapes. It's the rest of the year. There's this one. This is called a rational function. And of course, it's going forever. And this isn't perfect, but you get the game. Every single time the vertex is at 0, 0. Absolute value. And this is exponential. Okay? I need you to get good at these. How did I get good? I do it enough. So that's what I want you to do. So what determines if something is an even or an odd function is this. When you plug in negative x to the value of x. So if you look here, I'm going to zoom in a little bit. They're saying, hey, take negative x and plug it right in there. Now, if you plug in negative x, and you end up getting the same thing you started with, it's considered even. So if you plug in a negative number and it ends up giving you the same thing, it ends up being an even function. But if you plug in a negative and the answer ends up being negative, then it's considered an odd function. So let's talk about that, okay? And again, it's not because this is 2 and this is 3. There are many types of functions. So if I plug in negative x and I square it, what is that? Well, when I square anything negative, it turns positive. So that means when I plug in the negative, it's still the exact same thing. So that means this is x squared and this is x squared. Oh, by the way, this is quadratic. So it is even. Okay? If I plug in negative x here and I go negative x cubed, if I cube a negative, it stays negative. By the way, that's cubic. So, the original was x cubed, but when I plug in negative x, it turned to negative, so it didn't stay the same, so it's odd. If I was to graph this, it's here. So it's not on top of itself. Okay? If I do this one, and I plug in negative right to here, that's negative x, which is negative 1 over x. Which means now, instead of it being here, it's there. When I plugged in the original, it was this. When I plugged in negative x, it was this. So it's odd. Okay? All right. Now, the type is called rational. Okay, one sec. So let's look at the next one. If I plug in negative, well, shoot. If I plug in this, I get I square root of x. Well, wait a minute. That isn't the same, but it isn't the opposite. So it's not even. So if I plugged in this, I got this, the original. But then when I plug in a negative, I get I square root of x. That's not the opposite. By the way, this is called a radical function. So that means it got cut off here. And maybe it did because it's neither. It's not odd. It's not even. It's neither. Okay? Let's go to this one. If I plug in the negative, what's the absolute value of anything negative? Oh, it's positive. By the way, it's absolute value. So the original was this. Oh, and the new one is this. So it is the exact same thing. It's even. Okay? Now let's go to this one. I should have graphed this. I didn't. Absolute value, the exact same thing. That's why it's even. Okay? Now this one, I couldn't even graph it. I can't graph an imaginary graph on a real thing. This is exponential. Okay? So I plug the negative in there. So now it becomes b to the negative x, which is 1 over x. Well, wait a minute. That changed the graph completely. Oops, sorry. 1 over b to the x. So now that changed the graph completely. But it's exponential, and then we have b to the negative x. So that means it's not even, it's not odd. It is neither. So here's what I want you to see. Let's zoom out a little bit. So how do you know something's even? If you look, these two are even because they were on top of each other. So those are even. I don't know. Let's just say this. So pink, pink, they're exactly the same. Odd was odd and odd. They're a reflection of each other. They're the same thing, but there's a reflection of each other. These two, it's neither of them because, well, I can't even draw this and this won't be a reflection of that one. Okay? So even, odd, neither, or neither. Okay? All right, let's see what they want here. They want you to determine if this is even, odd, or neither. Okay? So let's figure it out. So, if I graph this, this is the parent. What is the vertex? 0, 0. So that means if I plug in negative x here, let's see what happens. So if I go negative x and I square it, I get x squared. Hey, that's what I started with. Even. Let me graph this one. First, what's the vertex? Negative 5, 0. Do the opposite. Okay. Now, this one's a little bit more confusing, so we might just have to multiply that. We'll figure it out. Okay. If I plug in negative x, okay, so now I'm plugging in negative x to that, and I simplify it. Some of you are like, well, I can't really tell if it's even or odd. So, what I would have to do is I would box this out. Let me zoom out a little bit. X, 5x, 5, x squared, 5x, 5x, 25. This is x squared plus 10x plus 25. I'm going fast on this because you're good at this one, okay? Negative x plus 5 squared. Box it out. I'll do this one a little bit more slowly. Square that. So I get x squared minus 10x plus 25. So here's the thing. We know it's not even because it's not exactly the same. So it's not exactly the same, so it's not even. Odd would be this is negative, and this is negative. It would have to all be completely opposite. But that's not true. These are the same, but these are different. So since they are not exactly the same, it would be neither. Because if you have x squared plus 10x plus 25, this one is x squared minus 10x plus 25. This is positive, positive. This is positive, negative. So it's like, are they the same or are they different? You can't tell. Okay. Now that means that if I was to graph this, the negative one, it would just be on top of itself. This one, what is the vertex? 0, 5. So I'm going to take negative x, and I'm going to plug it in. If I do that, I get x squared plus 5. Hey, they're exactly the same. It's even. How would I graph it? Up 5. Horizontal translation, 5 on the left. Vertical translation, 5 up. Notice the difference. No transformation at all. It's the parent. All right, x cubed. I'm going to take, I should know that this is a squiggle because I know it's the parent function. I'm actually going to do that in green because I want to get used to what the parent looks like. Ooh, this one. That's a parent. Let's see, any other parents do you see? Nope. Okay, so now I'm going to do this one. That's right. Negative x cubed. Well, if I cube a negative, it stays negative. So is it exactly the same? No. Is it the same but opposite? Yeah, this one's positive, this one's negative. So it's odd. Okay. If I was to graph it, it would go like that. It's a reflection. Let's do this one. If I do this one, I plug in negative x plus 5 cubed. I'm taking the x, I'm plugging it in. Now, if I was going to do that one, let me get a different color here. Just feels right. If I have x plus 5 cubed, oh man, this pen is not awesome, back to red. That means it's really x plus 5 times x plus 5 times x plus 5. Okay? So that means I would box this out, and I would get x squared plus 10x plus 25. And then I would box it out again, but this time it's going to look like this. X plus 5, x squared, 10x, 25. Let me do this. Let's see if my black pen works. X cubed, 10x squared, 25x, 5x squared, 50x, 125. Diagonals always go together. X cubed plus 15x squared plus 75x plus 125. Now, if when I do this one 3 times, I get the exact same thing, it would be even. If I did this cubed and I get this is negative, this is negative, this is negative, and this is negative, then they're all opposite, that would be odd. If this was positive but this was negative, then I can't tell which one it is, and it would be neither. So I'm going to do this just for time. And we know it was x squared minus 25. That's negative. Let's clear this out. If you're not sure how to box things out, I would do yourself a favor, and I would practice after the video and make sure you're good. Okay. The first one was negative when we had done it, and this one's negative. I mean positive, and this one was negative. So far, it's odd. Okay? In the first one, it was 15x squared. But this one, it's, let's see, this was positive, and this is positive. Well, shoot. That means they're the exact same thing. So are they odd or even? It's neither. Okay. What would this be? The vertex would be negative 5, 0. Horizontal translation, 5 left, which means it would be here. And that would be my original. Okay, let me zoom it out in a little bit. Okay, let's do this one. I plug in negative x to this one. Sorry, it's squeaking. If I cube a negative, it stays negative. Okay, they're not the exact same thing. They're not even. This one's positive and this one's negative, so that checks the odd box. But the problem is this is positive and this is still positive. So these are the same, but these are opposite, so it's neither. What would be the vertex? 0, 5. Vertical translation, 5 units up. Okay, oops, 5 up. You don't do the units, sorry. So that means that's like this, and we're there. So depending on the type of graph and where the transformation is can depend on what type of graph it ends up being. Okay? Here's what I want you to get with this one. Well, actually, we did that one on the previous page. You plug in negative x, so you get negative 1 over x. That's positive. That's negative. It's odd. Okay? This is a constant. Okay? So if I was to plug that or graph that, that's y equals negative 2.5. There isn't a negative x to plug it in, so it's the exact same thing. So it's even. And I don't care about this one. Okay? I'll talk about the homework in the next video.